Okay, I welcome you everyone. Today we are again here with our new upcoming session. This is Hydroponics Technology and its concept. I welcome Chandan Sen as well as Akshay sir. Akshay sir is a project manager in Farming Wave, and Chandan Kumar is a founder of Farming Wave. So today's session is all about hydroponics technology and its concept, where we learn different types of hydroponic system, the basic of hydroponic system. Those students who want to eager or want to know about the concept of hydroponic session. So we'll just start the session and let's have a good start. Welcome you everyone.
Okay, thank you, Tanujaji. I'll take it from here. So, hello everyone. First of all, am I visible as well as audible? Am I audible to everyone?
Yes, sir.
So, if you have any issue, just you can raise your hand in the middle of the meeting, and we'll respond. Okay. So, secondly, welcome you all in this humble webinar. We will be talking about hydroponics for 3 days straight. So, although the topic is very vast, but 3 days is enough to cover the basics of it and just enough to get you curious enough so you may venture into hydroponics in the near future. So, as you know, I work for the Farming Wave as a project manager, and Mr. Chandra Kumar, he is the founder of Farming Wave. Here we are dealing in various types of precision farming systems. Okay, so one of them is hydroponics, which we are going to talk about today in detail. So, first of all, can you just give me a general idea what should be the medium of this conversation? Would you like to be would you like it to be in purely English, or would you like to be some mixture of Hindi or English as it is? So, can you just write in the chat box, or you may raise your hand if you want to do this in English, purely in English. Okay. So I think a lot of you want to do it in English. Hindi or English is also fine. Okay, so a lot of people want me to do it purely in English. I'll continue with it in English, and I'll try to summarize it every topic in the end in a little bit of Hindi. So it's perfectly, yeah. Okay, it's good for everyone else. Okay, so first of all, let me introduce you to the two organizations that have collaborated to bring this webinar to you. First is a Farming Way. We deal in various types of precision farming systems, as we already told you, and the AgriYuth story. Okay, so these two have made this possible. So thank you, Chandan. Thank you, Tanuja ji. So this is a national training program for various modern agriculture techniques. Okay. Okay. So thank you for joining the workshop. And here we will be sharing whatever humble knowledge we have about hydroponics as well as various other farming techniques. Hope you will enjoy it and find it as fascinating as we did when we started this venture. So we will start. Okay. So how many of you all have heard about hydroponics prior to this? How many of you are okay, not audible? So you might have to check your audio output, Mr. Harmal, because I think it's audible to everyone else, right? Yeah, it's audible. So please check your audio output, please. Okay. So how many of you all have heard about hydroponics prior to this? Or if you're completely new to this, or I think a lot of you might be students in the colleges, you might be studying agriculture, you might have heard of this, but as this is a fairly recent technique, yeah, you might have heard about it, but see, the thing is, it's a fairly recent techniques. There's no proper course or structure of course in the colleges. So this is all about hearsay. हमने कहा है, हमने सुना है कहीं पे, उस तरीके से आपको नॉलेज रहे. But this is a program we will try to give you a brief idea of hydroponics, what hydroponics it is. Okay. So first we'll go. This is what we will go through in this 3-day session. Okay. First will be what is hydroponics, then the types of hydroponic systems. We will be teaching you what are the various types of hydroponic systems that are being used for the last 30 or so years. Okay, there have been many advancements in it. Many countries have adopted it in various different ways, whatever suits their geographical needs. Secondly, we will be talking about various types of hydroponic mediums and substrates. So as the types of hydroponics varies from country to country, from region to region, the substrates, the medium which is being used to substitute soil here is also changes from region to region, because what is the availability of that particular medium in that particular region, it's very important. So there are places where coconut is in very huge quantity, for example in India. So a lot of products that we use for hydroponic mediums are based out of coconut. Some places have this clay is very predominant in some geographies, so they use clay type substrates. We will read about them in next slides. Then we will be talking about general steps of hydroponics, how it comes about, how are we going to understand how it is different from the regular types of farming, regular agriculture practices. Then the crop cycles of leafy and fruity crops. This will be very similar to a lot of you people if you are students. If you're in BSc agriculture or some kind of other degree which deals in agriculture, you might have heard about leafy and fruity crops. You might have an idea of what their crop cycles are, what are the nutrient requirements. So as you will read through hydroponics, you will see some of the the things that are very uh, similar to what you have read about, but there will be some differences where you will be able to understand that this hydroponics is pretty much similar to what you have read about in for leafy and fruity crops, but it is slightly different in a way where it is very beneficial to us. Okay, then we'll delve into the environment where the hydroponics is used. Hydroponics is a system which cannot operate very well in open fields. There are very specific places where hydroponics has been successfully used in open fields. Most of it's still in protected cultivation. So the USP of protected cultivation, we get all the qualities of protected cultivation in polyhouses. In India, it's a very common thing. So we will be reading about types of polyhouses which are used for hydroponics. Then finally, we will conclude it with the benefits and advantages of hydroponics. And then we will tell you about our services and USP. We have been in this industry for quite a while. So Mr. Chandan, right from his graduation, he started with the hydroponic systems only. So he has a various years of experiences. All our team has a combined experience of at least 20 plus years. So we have been in this industry and we will try to guide you as easily as possible through this. Okay. So anyone has any questions regarding this? I think we will be covering most of it, most of the most of the knowledge about hydroponic systems in these 3 sessions. So let us start with the crux of hydroponics. Now, what does the plant requires to grow? There are only 3 things. First is water. Secondly, there are minerals. And thirdly is a growing media. So for general idea, when we are sowing any crop in the open field, what we have is we have soil as a growing media where the roots can take space, they can hold on to it and provide support for the whole plant to grow. That is first. First is the growing media, that is soil in this case. Secondly, we have water. Water is being used for various things. It can be used for providing nutrients to the plants. It can be used for it to, for regulating the temperature of the growing media and various other things also. Thirdly, we need nutrients. Now we have these three things. First is soil or a growing media. Secondly, we need water. Thirdly, the plant requires nutrients to grow. Now, if these are the basics, once we have understood the basics, we understand that these three things do not require, do not necessarily have to be from natural occurring places. Okay, you do not need to provide the you need to sow the seed in only soil to provide the plant with all these three things. These can be slightly automated, sorry, it can be slightly outsourced to man-made, uh, through man-made ways. What we can do is we can provide all these three things through man-made means. So coming to this is where hydroponics comes. Hydroponics, although we have tried to give these three things to plants through various other ways, but hydroponics is the first way where we have totally automated it, and we have been able to totally outsource this to man-made practices. Now coming to hydroponics, what is this? This is a soil-less plant growing method. Now the biggest thing with the growing crops, any kind of crop or trees, is that we have very hard time initially in mimicking soil. Now soil, what it does, it is also acting as a media. It is also giving nutrients to plants. It is also holding moisture, water in the form of moisture for the plants. So to mimic soil, we need to do a lot of things. So the thing is, soil, once we discovered that hydroponics can be used, it was a big breakthrough in science. Now this is a soil-less plant growing method. It is also the reason this is very fairly new, and it is also a very fairly odd thing to listen, that we can grow plants without any kind of soil. Now this is a soil-less plant growing method, and what we do in this is that firstly we use nutrient solutions. So any kind of nutrient that we are providing the plant is not coming from soil, it's not coming through its media, it's directly coming from water. We are using only water to provide it nutrients. So if the water is taken out of the equation, there is no other way that plant can get nutrients. Okay, there is no need for plant to be dependent on anything else for nutrients. Secondly, we are using growing mediums like coconut coir, perlite, and rock wool. These are the three examples. We have multiple different types of growing mediums. We have had hundreds of research papers written on growing medium. So there are at least 30 different kinds of growing media that are being used throughout the world, okay, in various forms. So the growing media mimics soil in a way that it helps the roots to take space. So it is holding on to the roots, so can the plant can stay upright. It can uh, you know stay in a place, and it is able to provide the space for water. So the water that is being used to supply the nutrients, it needs space in the growing media where it rests in the form of moisture, and the roots, the plant through its roots can take the nutrients from there. So the growing media itself does not have any nutrients, but it is a very good place for water to be stored. So we are providing water nutrients through water, mixed with water through this growing media. Now, when it comes to this, we reach a point where we have very efficient systems. Yeah, exactly, Neha. Water storage and root anchorage. These are the major two things that is required from a growing media. Now coming to this, that we have become very efficient in using this, because all these things are completely man-made. So we are able to reach a point, we have even we have been able to reach a point where we do not require uh, to use a lot of water. We have reduced the margin of error. So try to understand this. We have been able to reduce the margin of error. We have reached a point where we will provide only that much media, that much nutrients, that much water that is required by the plant. So in open field, what we used to have a problem is that we need a lot of area, a lot of soil to plant a particular, plant something. So when we shift it to hydroponics or any kind of precision farming, what we can do is, for example, we are using only that much amount of growing media that is required for that roots. Nothing more, nothing less. We are only using that much amount of water that is required by the plant itself. Nothing more, nothing less. So this creates an environment where everything is being utilized with great efficiency. So what happens is this is efficient in various ways. We are able to use less water. We are recirculating the water. It's one of the ways that we reduce the water usage. We will be reading it in detail. Then we are also efficient in space saving. So we have vertical farmings. We can place racks of growing media one on top of other. We can we can grow multiple types of crops in compact spaces. We do not have to rely on large spaces. Then we have also been able to utilize the efficiency of nutrients. So we need only that much amount of nutrient that is required for plant to grow so that we as humans can consume it. So we do not need to waste a lot of, for example, there is a fruiting tree. If we are using a lot of nutrients to make it very sturdy in open field, we need to make the tree itself very sturdy so that the fruit, it can withstand various winds and everything. But here what happens is, as it is being grown in a very controlled environment, we only need to give the plants enough nutrients so it can stay upright and it can bear the fruits. So the nutrients, they are, first of all, they are not being washed away by the water and everything. Secondly, we can specifically uh, tailor these nutrient mixes for our needs, for the plant's needs. Then we have the second last thing, the pest control. Now this is a protected cultivation system which gives us a very good control over what kind of pests and what kind of diseases we are going to tackle. In the open field, there's no control over this. But as we are using growing media, which is not soil, which has almost zero, almost very much reduced microbial growth. So we are reducing the soil-borne diseases. We will be using very good quality water. So there will be less waterborne diseases. And thirdly, we are using a controlled environment. So there will be very less airborne diseases. So we have effectively eliminated these three kind of diseases. The first is the waterborne, then soil-borne, and then airborne. Now these three diseases are effectively reduced to around up to 90% of these diseases are eliminated. So whatever little things we have to face, we are able to tackle it very effectively. Now, sustainability, when it comes to sustainability, we have a very eco-friendly and year-round growth. This is a very important thing as it's a controlled environment and everything is being tailor-made for the plants. We are able to make it in a way that there is almost zero wastage of resources, and the even if you are using some pesticides and everything, they are not being run away in the water. It's there are multiple layers to this, multiple ways there where we are able to make it a eco-friendly project. As compared to open field farming, we are able to minimize a lot of this loss of these chemicals, where it can seep into the soil, where it can go into the water bodies and everything. So we have made it in a way that we can reduce the environmental and ecological impact of this farming. to an extent that we do not have to worry about any kind of pollution. So the sustainability factor is a very important one here, because we are able to reach the sustainability thing. Okay, so this is also a very important thing, because it has, in the recent times, it has become a the deciding factor for hydroponics. So apart from the you know obvious better ROIs, uh, sustainability factor has pushed hydroponics to newer limits. So there are a lot of people, lot of countries adopting hydroponics because of its sustainability more than anything else. Okay, and then lastly, the year-round growth. We have a lot of control over what seasons we can grow what. We will be discussing about it further slides. Okay, now coming to the advantages of hydroponics. So before this, uh, I think a lot of you have understood what I'm talking about when I'm talking about hydroponics, right? So do you have any questions about these points on the left side of the slide? Any kind of confusion? Just let me know, because we'll be clearing it as frequently as possible to reduce any kind of confusions. So no questions. So pest control. Okay, so the thing is, uh, no, actually the thing is, Miss Jasprit Kaur, the quality of water is a very big thing here. So whenever we are establishing some kind of hydroponic plant, we try to make sure that there is a very good filtration system for the water. So when we are utilizing any kind of filtration system, for example, we are using RO water for mostly our NFT and DWC hydroponic systems. We only use RO water, RO filtered water. So when we're using RO and UV techniques, if we are using it in open field, we require at least 100 times more water than hydroponics. So it's not possible to use a very good quality water because it's not very cost effective. But when it comes to hydroponics, the requirement of water is almost 100, only 1 to 2% of what it is required in open field. So what ends up happening is that we are able to filter that water out very cost effectively. Secondly, Mr. Bharmal, you wanted to know about pest control. Okay, so what happens in pest control is that see, pest also comes from all these three sources, either from air, from water, and from soil. There are only three ways the pest can enter, start feeding on plants. So for airborne diseases, we have a very good protection system in the form of polyhouses. Okay, or if it's indoor hydroponics, it's protected by walls. Secondly, for water, as I already told you, there's a very effective filtration system that can be used, and it's cost effective also. Thirdly, we are not using soil. Soil has a lot of microbial growth, and it is a self biodegradable thing. So anything that goes into soil, it will start biodegrading, and soil itself is very houses a lot of organisms. But these growing media are very well they are very thoroughly cleaned before using for hydroponics. So there is a very little chance that any kind of bugs or any kind of foreign material will be in these growing media. So we have eliminated all three kinds of diseases also, and all three kinds of pests also. There will be times in hydroponic systems that maybe some kind of pest may enter, and it is also very common. Every one crop, there will be one or two instances that will find some maybe some hole in the polyhouse, some mismanagement where the pest has entered. But the pest control is very effective in that way, because we are not at any point of time dealing with 10 different kinds of pests. We'll be dealing with one or two kinds of pests at the worst. So it's also very effective pest control. So I hope, Mr. Bharmal, this is clear. okay, Manoj, you have asked, can we use the water for any other purpose that is used once for hydroponics? As far as NFT and DWC are concerned, it can be recirculated. And the second one, the water is not wasted as such, but it will be utilized by the plant. So we will be discussing about that in the further slides, Manoj. Is that okay? Because it will be very confusing for everyone else. We will discuss this point in the further slides. Now, types of grow crops that we can grow in hydroponics. Okay, Preetham, we'll be discussing this in further slides. We have a totally different topic. That is a totally different topic. Okay, so let me move ahead and tell you the advantages of hydroponics. I think this will be a quick conversation because I think when I introduced hydroponics, it is very easy to understand what are the advantages. So first of all, no soil is needed. Okay, the soil, because very sterilized and very good quality soil is very hard to find. So no soil is needed. So this eliminates the hunt for right kind of land for hydroponics. Okay. Secondly, water conservation. Now, water conservation, it's a very important thing because water is also one of the key ingredients which is subject to availability. When it comes to farming, it is very hard to find good quality water. If you are in some coastal area or some kind of area where the water table has been depleted, you will not be able to find very good quality source of for water. So water conservation is one of the advantages of hydroponics, which helps it grow at the pace that it is growing right now. Now, the control of nutrition as per needs. This is very unique to hydroponics and a little bit in the drip irrigation also, that we are able to control the nutrition as per needs. Otherwise, in any kind of field irrigation, it's very hard to control the nutrition levels in any kind of plant. Then the stable and it is stable and provides high yields. Now, when we are, it's all very sophisticated techniques that we are using. So obviously, the yields will be, yields will reciprocate that. So we will have better quality yields. How we can control the nutrition level? Okay, so the as far as the nutrition level is concerned, we have a very separate topic coming, Preetham. We will discuss about that in detail. It's a very technical thing. We have different kind of nutrient solutions and various kinds of ways that we can provide water and solutions to the plants. Okay, it's a very detailed topic. So these are topics which require months for agronomists who are working in the farm. They have to dedicate months to understand what are the nutrient requirements of the plants in hydroponics. Now, then coming to the pests and diseases are easier to get rid of. Okay, so pests and diseases, as I've already told you, the waterborne, soil-borne, and airborne diseases have been taken care of, and very effectively so. Now, Neha, you're asking what about intercultural operations? Yes, the intercultural operations are possible in hydroponics, but there is a limit to how we can do this. Okay, so let me cover these topics when we are talking about different kind of hydroponic systems. There it will be very easy for us to understand things. Okay, Ms. Neha, we'll cover these topics once we reach the types of hydroponic systems. Okay, now the ease of harvesting. Now, harvesting is when we are talking about hydroponics, the thing is that when we are scheduling the harvesting, you have been a part of open field cultivations. You may know that when we say that something is a 30-day crop, now in open field, it can take 25 days also, it can take 50 days also. It's a very hard thing to predict a lot of things in open field. But in hydroponic systems, everything is very sophisticated. We are able to reach our targets in terms of nutrients, also in terms of harvesting also. So we are able to reach the targets, and we have a very particular window where we can do start the harvesting. So we are able to meet that targets. Secondly, the harvesting itself is very easy. How it's easy that we have proper spacings can be managed in hydroponic systems. The harvesting itself can be very much, there are various techniques that we can use. So we can use the harvesting is done in a way that there are literally zero wastage. So the harvesting is very sophisticated in this. Obviously, it's very hard for me to explain how harvesting it is easy. So once we reach the types of hydroponic systems, once you see a couple of visuals of hydroponic systems, it will be very easy for you to understand. Okay. Now it's better for consumption. Now this is the biggest topic, and the biggest advantage of hydroponics is that it is being utilized, accepted in the urban population. Now, how many of you have heard of residue-free farming? So residue-free products. Have you ever heard of residue-free vegetables? You can raise your hands or write in the chat. Okay, so let me give you an idea. Residue-free products are refer to the vegetables and fruits that have no chemical or pesticide or some kind of this kind of residues in the final product. So for example, we have two different kind of systems in place where any kind of vegetable or fruit is considered fit for human consumption. The United States and that American part usually resides on how it is grown. Okay, if it is grown on soil and there are the pesticides and everything is under the limit, it is considered organic. Okay, but it has to be grown on soil. But European standards are far better than this. They have accumulated hydroponics also in this. Okay, residual free. Okay, residual free. So residual free product is the product which has no residue or very traceable amount of residue, non-traceable amount of residue, which is fit for human consumption. That much amount of residue of chemicals and pesticides and herbicides and everything. So any kind of chemicals that we are using on field, if in the final, when we have the final fruit or final vegetable, it does not have the residue of those chemicals. That is only possible when you use the exact amount of these chemicals that are required by the plant. So for example, you have 10, for example, there is a plant that has 10, 10 insects on it, and you need 10 ml of pesticide to kill all of them. But if you are using it in open field, you have a risk of it getting evaporated, it being washed in the rain and everything. So you will be using 100 or 150 ml of that. So it is being used 10 to 15 times extra. But when you have a controlled environment, you do not have to worry about these problems. You have to worry about very less. So you will be using 10 or 12 or 13 ml only. Just for the margin of error is greatly reduced. Organic products are residual products. Yeah. So one second. So the residue of these chemicals is greatly reduced in the final product because the whatever chemicals we are using on the plants, it is being utilized in the plants. So there is no residue. The biggest problem with using urea and all kinds of these uh, fertilizers is that the fertilizers leave a residue in the chemical form in the final product. So these residues needs to be eradicated. That can only be done when we use the exact amount that is required by the plant. Okay. So coming to the question of Apurva Mishra, that organic products can be said as residual free products in some countries. So for in the American standards do not, they have different categories. These are something is organic, then there is something is residual free. These are two different things. So residual free is very good. You can compare it like residual free is A grade, and organic and residual free, that is A plus grade. Okay, but European standards are different. So they will consider residual free as good and even better than organic. So yeah, it depends on the country. Okay. Now, it depends on the country which is considering it residual free or organic. But it depends on the country. India, as of right now, follows the US standards. It's or residual free is more expensive than organic in some areas, obviously. So you will have to, go to a particular, organic stores. There are several organic stores that you have to visit. The price of residual free products and organic products is at least 2 to 3 times of those of natural origin. So whatever price you see in mandi, it's at least 2 to 3 times that for the residual and organic products in the retail market. Now, is it clear? The concept of residual free, is it clear? So this is also one of the biggest things that is pushing it in urban India. So in the urban population, there's a huge demand for organic and residual free products. So residual free and hydroponics are being used interchangeably. It's very common knowledge in a lot of people now, because there have been a lot of webinars in the past 10 years or so that we have witnessed that in the last 10 years, a lot of people have shown interest in hydroponics. They have joined various webinars like you're doing today, and they are being educated that hydroponics provides a very good residual free product. So when you go to Blinkit or I think Swiggy, Instamart or anywhere else, you can search for example, you can search for red capsicum, and then you search for hydroponically grown red capsicum. You will see a 10 to 12% increase in the price for hydroponics one, because it is residual free and it is being marketed as so because it is residual free, and we are getting better prices for that also. Hydroponics and aeroponics. Okay, so these are different techniques. We will be coming to techniques in the new Ms. Shambhavi. So the difference between hydroponics and aeroponics you're asking, we will be coming to that in further slides. Please be with me. Okay. Now coming to this, now challenges faced by the farmers. Now, these are some of the challenges that are being faced by farmers in the open field systems. Okay, I'm not talking about hydroponics. I'm not talking about the various protected cultivation systems, which still do not comprise even 10% of the farming systems in the country. It's a shame that we are very far behind in utilizing newer age techniques. Now, this climate change, this unpredictable weather, and droughts and floods, these are very big challenges for farmers who are doing it in open fields. Now, they have no way of predicting the weathers. Is even if IMD is providing the weather details, it's very hard for them to predict the exact timings of rain or how much rain will be this year. So anything that can be predicted will be in short term, but the crops are not short term crops. Even the most shortest term crop will be 30, 50, 40 days. So you cannot predict the weather for next 30, 40, 50 days. You cannot predict if there will be any flood in 30, 50 days. You can predict on a couple of days in advance at best. So this climate change, it has become more predominant also in the recent times. This is a very big problem for farmers. Now, this is being solved with various techniques. We'll be discussing them in depth, but you need to understand that climate change is a very big problem that farmers are facing. Then coming to the pests and diseases part. Now, as I told you, there are three different kinds of problems, three different ways that any kind of pest or diseases can come to the plants. These are airborne, waterborne, and soil-borne. Now, all these three factors have been heavily polluted over the course of last 50 years or so. Soil is being, overutilized, using a lot of chemicals and a lot of fertilizers, excess fertilizers. Then the water quality has degraded a lot in the last few years. Sorry, someone was saying something. Okay. So the water quality has also degraded a lot in the past few years. And the air quality, as we know, the AQI is very high right now. So, fighting these pests and diseases has become a very tough challenge for farmers. Okay. Then the soil degradation. Soil, as I think we talked about it in the pest and diseases thing, the soil has lost its fertility. So at a time when there was a time when the fertilizers were being used to make up for the limited amount of nutrition that soil could provide. That limited amount of so nutrition has even compacted more. So for example, if a farmer needed to replenish 10% of the nutrients that the plant requires through other media, they have to use at least yes, they have to make up for at least 50% now. So a lot of the fertility of the soil has been degraded in the past. Then there is erosion through floods, through winds, and there are various different means the soil erosion happens. But it is a fact that soil degradation is a very big problem for farmers right now. Now, water scarcity, as we know, there is a limited irrigation practices that we have. Even the drip irrigation system that is being considered, the holy grail of irrigation system, that is not being utilized in a lot of by a lot of farmers because a lot of lack of resources, maybe lack of knowledge. But there is a resistance even in the urban parts of urban farmers, that a lot of people are not very have not utilized the irrigation systems. The water scarcity as a result has become a problem because open field irrigation requires a lot of water. There's a lot of wastage of water every year for farming practices. Then coming to market access. Now, price fluctuations, middlemen, I think if any of you have been a part of open field system, if your parents or grandparents have been part of farming industry, they will know that growing a particular product might be a challenge, but it's not as challenging as finding a right buyer for the uh, product, because a lot of Indians do not want to pay a lot of premium for normal vegetables. But that is a thing that is being changed in the urban area, in the urban population. We are willing to pay a little bit extra for good quality products. So that has changed. That has given rise to these hydroponics and drip irrigation systems and very kind of precision farming systems to improve the quality of produce that we get. That also reflects in the price of these products. So market access, these price fluctuations and middlemen, that can be greatly reduced by getting a very good quality produce. So maintaining that quality of produce. So that way we can have a very good, we can reduce this price fluctuation by a lot. Then the credit and loans, the farmers face a lot of these things, that any kind of loan that they try to take, they are not through legitimate means, not a part of, as lot of farmers are not part of the banking system. They do not have access to very good quality very good value loans. Now this lack of financial support, what it causes is that people are very afraid to bring in newer technologies into their farming methods. So that is a problem that farmers face that we need to eradicate, and that is only possible through we have to push these newer age technologies even into the rural areas. So then coming to the technology access. Now, as these technology penetrates the urban area, it will slowly start to get into the rural areas as well. But for that, people from rural areas will have to take initiative and learn about these technologies. So people, a lot of you, myself included, our parents hail from very rural areas. For example, we have ventured into these newer kind of agriculture practices. When we go back to our villages, we are able to give them a lot of new insights in the newer technologies. So which one to utilize, which will be most beneficial for you. So these kind of things that we can carry back to our villages, to our previous generations. Yeah. So the previous generation farmers are even in the new generation farmers are being getting benefits from this because we are learning. Okay, so everyone who learns passes this knowledge on. Now coming to the labor shortage. So a lot of farming practices require a lot of labor, but this is not a continuous task. So we will be requiring a lot of labor during the plantation, during the harvest, during the pruning and training of the plants. But these are small patches of time. For the small patches of time, uh, for a lot of part of the plant's crop cycle, there are times there's a lot of very good amount of patch, or almost 50% of the time, that you do not require a lot of labor on regular basis for that crop. So it's very important that these labor shortages occur because of that. And then there are problems like migration and aging workforce. A lot of labors that we find are very old. The newer generation does not want to work in the fields. They do not want to do the manual work. But the problem is we need to reduce this amount of manual work that is required through modern means. Because anyone in our generation might find it very hard to use a very traditional hull, very traditional flying tools, but we'll be very comfortable in driving a tractor. That might be even exciting for us. So the aging workforce, the workforce that is traditionally required in the labor, in the farming system, that is required in the farming systems, has aged. Now the newer farming systems will require newer workforce, newer will be able to utilize the newer workforce. Now, then coming to migration. Now, a lot of farmers, their children will go to newer places to find jobs that are well suited for their, they're well suited for their educational qualifications. But that can be reduced. That migration can be reduced once we, utilize newer technologies in the farming industries. We have to make farming more technologically advanced and more feasible, and also more appealing to the younger generation. One of such way is hydroponics and other, you know, precision farming systems like drip irrigation systems. We have a lot of techniques that can be utilized there that will boost this. Now, coming to storages. Now, storage problem. I think this is a major problem which is paired with the market problems. So the price fluctuation actually happens a lot because of these post-harvest losses. So I think this is a time, I think this is May. So we are at a time then we'll be shortly, a couple of months later, we'll be facing shortages of onions, or sorry, for tomatoes. So in the rainy seasons, it's a very hard to keep the tomatoes fresh. In a few days, because of the humidity, because of damage, because of rain, there will be a lot of losses of tomatoes in the market. That will give rise to price fluctuations. That will give that the even the rising prices will only benefit the middlemen, because the farmers will be selling at the same price, and those who are able to sell, they will be lucky ones, because a lot of these tomatoes will not be able to find a good quality storage space, like cold storages. They will not be able to find them on time. That lead to a lot of loss. Now these are the challenges that are being faced by the farmers. Now every one of these challenges is being addressed by newer farming technologies. Okay, now specifically when we are discussing hydroponics, now we will be discussing hydroponics, so we will be discussing through that lens, how hydroponics farming is going to tackle those. Now, first of all, why this is the answer to the global food production. Now, as 90% of the water is being saved in hydroponic farming, this tackles a lot of challenges. That includes the water problem also. That includes the cost effectiveness of the irrigation systems also. That uh, tackles the pest problems also. As 90% water is being saved, it indirectly trickles down a lot of other benefits also. Okay, I think I have made this clear in the last few slides, that as only 10% of the water is being required in hydroponics farming, what we are able to do, what we are able to achieve through this is that we are able to use good quality water. We are able to use a lot of filtration technique, and the amount of water is being utilized less. There's a less wastage, and it brings about a chain of effects that ultimately leads to a better quality produce and less amount of resources. Then we have 10 times more yield grown with soilless farming. Now, 10 times, it is a cumulative figure where we are able to achieve by reducing the amount of resources across the board. So we have less amount of land, we require less amount of land, we require less amount of water, we require less amount of nutrients, we require less amount of money also. So all these figures, if we compare it to the traditional farming, we have 10 times more yield as far as the resources go, the amount of resources go. Okay. Then India is the second largest market for hydroponic produce. Now in Asia, obviously, you can guess the first one. The largest market is China. Now China is one of the first countries that actually adopted hydroponics and polyhouse farming uh, in the as early as in 80s, in the late 80s. So they are very far ahead than we are. But that also gives us an idea that at the place where China is, we can easily reach there because the technologies have been, have become more refined now. They are more accessible to low margin farmers. So we can utilize that because we are the second largest market for hydroponic produce. We are a little bit behind China, but we can surely catch up to them. Now, because we are second largest, we also need to understand that we have the highest population in Asia. So we can easily predict a very good quality, very good growth in the upcoming years. So we will be hydroponic systems, especially the hydroponics and polyhouse systems. They will be attracting a lot of, they will be attracting a lot of attention also. They will be attracting a lot of capital also, both from international and national. Means that a lot of people will be investing in the Indian good quality food produce market. So this is a very good opportunity. So but Mr. Bharmal is asking how organized this sector is. That as what I hear, that we have to find customers of our own and how to fix up selling price. So as far as the second part of your question, Mr. Bharmal, we'll be discussing later on in the slide. But for the first part, how organized this sector is. So as far as we are concerned right now, there are a lot of new players in the industry, and this has started organizing itself. The hydroponics and food produce sector, it has started organizing itself in the last 5 years only. Before that, our organization was nil, non-existent. So there are a lot of brands that are building upon this good quality produce. So you can look at the Reliance Fresh and their organic food factory, and there are a lot of new players that are coming up that are organizing this market. So it's a very recent trend, and there's a lot of scope in organizing this. Okay, the sector will be organized in a few years, but that also means that is a lot of opportunity for growth. If you are an early player, as we are right now, if you start hydroponics right now, in the next 5 or 10 years, they will be benefiting a lot compared to people who start after 10 years. So it's a golden time. Okay, the second part of the question, can small player tie up with them without manipulation involved? Okay, Mr. Bharman, this is a very, very specific question. You are asking whether small players can be a part of this industry as easily as the large players have entered into the market. So it's a very good question, but it's yeah, it's the type of question which has no very good answer. So you have to be cautious enough. So this is something that we'll discuss in detail after we have grown the crops. So these are the kind of questions, obviously, it's very hard to answer for me or anyone else because there is no right answer to this one. We will discuss this once you're actually willing to enter into the actual market. Then these issues can be very easily tackled. but that is what our team is for here. So farming ways also helps in actually finding the right buyers for you and guiding you on how to buy farmers. So this is a thing that requires a years of practice. So I think this for this you will have to connect to the one of our executives who works in the sales. So he will be able to guide you well. Okay, so coming to this, that we are expecting a 14% compounded annual growth rate. So this is the compounded annual growth rate, CAGR. It is expected to be 14% from 18 to 25. So an yearly average 14% growth is very big in an industry as unorganized as food industry. Okay, food products industry actually. Now coming to the basics of hydroponics. Okay, so I think this is very obvious that it uses 1/10 of the water that is used in soil. And as far as the hydroponics is concerned, we can uh, easily understand how. Now, I think it's very fairly easy to understand how this 1/10 of the water is actually helping us find more and more benefits also. So there are a lot of benefits that are tied to this 1/10 use of water. Then plants can be grown in nutrient solutions. As the plants are being grown in nutrient solutions only, so this nutrients uh, can be tailor made for our plants. Secondly, they will be utilized in a very limited quantity. Okay. Thirdly, and I think this is a thing that I did not address it in the last previous slides, there is no weeds to deal with, and there is less space and higher yields. I think this is obvious, but the weed problem, that is also a very big problem, that weeds are a very problem when we are working in the soil. So not only they uh, you know mm, take over more take over the nutrition that is meant for the plants, they also take over the shade. They can at times provide shade to the plants. That can create a big problem. The plants will not get enough sunlight. Thirdly, the plant will have to compete with the weeds for nutrients as well as water. So the weeds, for us to tackle weeds, the labor required is very large. So a lot of people will end up using weedicide. That will leave a lot of residue also in the open field farming. So weeds is a problem that have many sub problems. So many problems that are uh, linked to weeds. So as we have no weeds to deal with in the hydroponic system, everything is managed by, managed very sophisticatedly. So as we have no weeds to deal with, the number of problems that are byproducts of weeds are also greatly reduced. So this is a very important, also a very important point. If we are, some of you are making notes, to also marking that having no weeds in the existing system, it's a very huge advantage because of this. I hope I made myself clear. Now, before I move on to hydroponic system, different hydroponic system, any you know question regarding this last few slides, especially in why hydroponics is important right now. Now, before we move on to what hydroponics is and the technical, okay, do we need, okay, Mr. Zaini is asking, do we need to make nutrient solution? Okay, nutrient solutions. Yeah, you need to make nutrient solutions. We have pre-made nutrient solutions for a lot of crops also. As I told you, this is a sector which has seen a lot of research in past few years. So there, the roads have been paved for you, for newcomers right now. So if you had started this 10 years ago, you might have to make your own concoctions and everything. But this is a time where we have made it in a way that a lot of R&D has been done by us, us, us as in a lot of companies. We have done a lot of R&D that is not necessarily has to be done by you as a consumer. Okay, so yeah, as far as your question is concerned, do we need to make nutrient solution? The answer is yes and no, depending on what kind of crops you want to do and how much involved you want to be in the hydroponics. But this can be discussed in the further slides. You do not have to worry about that. So Mr. Naveen Kumar, you want to understand about TDS measurement. So this is a very on-field activity. I can give you a brief when we are in the technical part of hydroponics. But as of right now, I think this will be very confusing for all of us. TDS measurement is a very practical thing. Practical as in on-field. Once until and unless you are actually in the field working with hydroponics, there's no point in confusing yourself with the terminologies and various technical things. It will be confusing at this point of time. Okay, so should we start with the hydroponic systems? So from now on, we will be getting a little bit of technical. So I would request you guys that if any one of you is taking notes, so um, get serious a little bit, and you will have to take more notes from now on. This will get a little bit technical. Okay. So anyone is, although we will be, you can just take a screenshot of the PPT, and it will be very easy for you to follow along in the revise after you get home. Okay. So coming to the NFT, so hydroponic systems. So as I told you that there are three different components in hydroponic systems that we are trying to replace as compared to the uh, open field system. We are finding a new growing media other than soil. We are trying to find, there will be a recording, Mr. Anna Patra. You will get a recording, but yeah, it's better to take notes in the recording so you can directly skip to the part where you want to, understand things. Now, coming to the NFT system. Now, hydroponic system, as I told you, three major things. First, we need to find a brand new growing media other than soil. Secondly, we need to find a way to give water to the plants, and through that water, we need to provide nutrients to the plants. So, when it comes to designing a hydroponic system, we get two different things. Firstly, how are we going to give the water, and secondly, what is going to be the growing medium. These two things, these two factors actually are so varied that they end up with different mix and matching techniques. We are able to uh, find different types of systems. These list of systems are endless, and they keep growing every year. Every year there will be a paper written on one new system that is being designed by some scientists in Israel. So as we know, Israel is the father of this technology. They have developed this, and there are a lot of newer techniques that are being developed in India, in Israel, and in US. These are three major players right now, and China also. Okay. Now, one of the most common techniques that is uh, that is used in NFT systems, the nutrient film technique. It is the hydroponic system that is easiest to understand. Okay, and easiest to manage. You will see a lot of people who are binding up a simple NFT system for their homes because this is very easy to understand. Okay, now just look at this diagram. Okay, so there is a reservoir of water. So the water is being pumped from here, mixed with nutrients, and it is being trickled down there in this long, long pipe. Let's call it a pipe for simplicity of understanding. Now, what happens is that this water, when it is being drained to the from the other side, this between this journey of water. Okay, I can use Hindi language also. Okay. uh, so जो हिंदी में मेरी बात समझ रहे हैं, just take this for example, for instance, कि आपका जो पानी है, the water is coming from here through a nutrient form mixed with nutrients. यहाँ पे ये trickle down कर रहा है. From one end it's trickling down drop by drop, and from the second end, from the next other end, it is trickling down back into the storage reservoir. अब क्या है कि यहाँ पर एक न्यूट्रिएंट की फिल्म बनी है. Now, what I mean with film is there is a thin layer of water. Now, film is actually called layer. Film refers to layer of water. There is a thin film of water that is constantly flowing in this NFT system. It can be made stagnant also, that is a different thing. But there will always be a film of this nutrient rich water जिसमें कि roots suspended रहेंगे. There will be roots will be suspended in a nutrient film of water. The water film that is full of nutrients, the roots will be suspended in it 24/7. Now what this ends up doing is कि roots do not require to grow very much in order to reach out into the soil and find nutrients. जैसे ही रूट्स थोड़े ग्रो हुए उनको वहीं पे वाटर मिल गया, वहीं पे न्यूट्रिएंट्स मिल गए. They do not have, the plant do not have to waste a lot of its energy, a lot of its growing to actually grow the roots into the soil. So what ends up happening is a lot of nutrient will directly go to the shoots or the upper part. Are you getting my point? One second. Okay. So are you getting my point? There is a film of water जहां पर हमारे रूट सस्पेंडेड है 24/7. So what this does is that the roots do not need to grow extra to reach out into the soil. जैसा कि उसको सॉइल में करना पड़ता, कि रीच आउट करना पड़ता नीचे जाकर किसी तरीके से न्यूट्रिएंट्स और सॉइल को खोजना पड़ता सॉइल में. But they do not have to do the same in this system. Now this is one of the most effective systems and most widely used systems for growing small plants, जहां पर कि हम लोग एक फिल्म बनाते हैं पतली सी वाटर की और एक पाइप में जो कि वो फिल्म कांस्टेंट रहती है. This creates a very good nutrient film technique. This is called nutrient film technique. Okay, Miss Anna Patra has asked a question. After the plant uptake, the nutrient concentration in the reservoir will decrease. So then what to do? Now, this obviously, after a point of time, this reservoir will become less, become slightly less concentrated in nutrients. तो हम लोग को हमें क्या करना पड़ता है कि we have to add nutrients. We have to maintain that TDS of the water. So TDS is simply, you can say, a ppm, parts per million. So there is a meter we have that measures कि 1 million water particles में कितने पार्ट्स जो है हमारा कुछ फॉरेन मटेरियल. फॉर एग्जांपल देयर इज अ 10 ppm, मतलब 1 मिलियन वाटर पार्टिकल्स में 10 जो पार्ट्स हैं वो अलग अलग टाइप के न्यूट्रिएंट्स हो सकते हैं, वो कुछ और क्या कहते हैं मिनरल्स हो सकते हैं, वो है. तो दैट ppm इज अ वेरी गुड वे ऑफ फाइंडिंग आउट कि हमारा कितना न्यूट्रिएंट रिच है वाटर. तो हमारे पास जैसे ही हमें लगता है कि जो रिक्वायर्ड लिमिट है उससे कम जा रहा है, इट्स गोइंग बिलो द रिक्वायर्ड लिमिट, we will refill it. That is a very on field technique again, that how to do that. This will be done, that you will be able to learn only this only after you have spent a couple of months in the farm itself, और आप रेगुलरली उसको रिफिल कर रहे हो वाटर को, वाटर में न्यूट्रिएंट्स को. So after a time the water will also decrease, the nutrient level in the water will also decrease. So you have to keep refilling it, but it's fairly easy that you have to do it once or twice a day. उतने में भी चल जाता है. For more sensitive crops, you will be using an auto doser or something like that that maintains the level of nutrients on a minutely basis. हर एक मिनट में वो चेक कर रहा होगा. They will be, it can be totally automated. This is a field that can be totally automated. And these totally automated NFCT systems are being utilized in India, in indoor farms also, in hydroponic farms also. And we have personally built these fully automated systems at farming wave. So farming wave has experience in that also. Secondly, I think Mr. Gopal Yadav is asking, nutrient pump and air stone are connected to each other. Now, what is air stone? So what happens is that this water also need to be aerated. इसमें oxygen level को भी हमको maintain करना है. So the aeration makes sure that it is the oxygen level is also maintained in the system. सिर्फ nutrient level नहीं, हमें oxygen level भी maintain करना है. It's as simple as that. It's nothing complex. So what we can do here is, what we need to do here is that we need to understand this whole system can be automated. This is a very simple system to understand. And thirdly, it's one of the most widespread systems throughout the world for growing small plants. This is a very important thing. For small plants, it's one of the most effective systems and most widely used systems. So anyone has any other question regarding the NFT system? Okay. What is this one? What is air pump? Okay. What is air pump? No, air pump is something that is directly, infusing the water with oxygen level, increasing the oxygen level in the water. So air pump will, that will push water through an air stone. So अगर आपने कभी ट्राई किया है, you try blowing water, air into water, it will directly just bubbles उठेंगे and it will, hello, okay. So what happens is that the water, sorry, if you try blowing air into the water directly through a tube or pipe or anything, वो water से air वैसा का वैसा वापस आ जाता है. So what air stone does is that it provides very small spaces for the air to flow out. What ends up happening is कि water अच्छे से ज़्यादा अच्छे से aerate होता है. ये आपने एयर स्टोन और एयर पंप का कॉम्बिनेशन शायद आपने एक्वेरियम में भी देखा होगा. So have you seen an aquarium? So to keep the aquarium oxygenated, we use an air stone and air pump, combination. हम लोग डायरेक्टली पानी में हवा नहीं फेंक सकते, हमें इस तरीके से फेंकना होता है कि एक्चुअल में वाटर एरेट हो. Okay, yes. So Mr. Bhamal, you have an aquarium at home. So it's pretty much a similar concept. जैसे आप मछलियों को ऑक्सीजन रिच वाटर देने के लिए आप यूज कर रहे हो, सेम वे में हमें जो वाटर हम लोग प्लांट्स को दे रहे हैं वो भी ऑक्सीजन रिच होना चाहिए. फॉर दैट वी यूज एन एयर स्टोन एंड एयर पंप system. Okay. So any other question? Okay, I think made it clear. So next, let's move on to the next system of growing small plants. Now, the thing is, in this system, what ends up happening is that now this is a very easy system to understand once you have understood the NFT system. So NFT system में हमारे पास क्या था कि there was a thin film of water जो हमें at all times maintain करनी थी. We have to maintain that film of water so that our roots are in contact with this film of water, nutrient water, and there's a little bit of space for air. So the roots are aerated also, they get enough air also, and this film had to maintain. But what was different in this system was that these plants are very evenly placed. So for example, here we will have what will happen is that we will have small holes in these pipes where these plants will be, placed. Now, but what happens when there is no such limitation that we have to keep the plants apart? Okay, so what happens? We do not have to keep these plants apart. We can put them fairly close to each other. So when we remove that limitation, so we know we can control this water very easily and we can afford to keep these plants even closer then what we'll do is we will utilize a ebb and flow system. Okay, what we'll do is we will utilize this ebb and flow system. Let me erase this. Okay, now what the main difference between these two is the difference in the uh, plant distance. Now this is a single pipe. What will end up in happening in NFT systems is that we will have single pipe like this with let's say 20 or 20 plants, 22 plants. Then we will have another pipe with 20 or 22 plants, which will have a same type of system in a single line. Now there is a 1 second. Let me show you a picture of NFT system. If we have one, this will help you understand. Now this is an NFT system. Okay, so there are different pipes that are being utilized. They're isolated from each other. There's a very very good amount of distance between these two plants. But what if we do not require this much distance between the plants? What we can do is we can keep them very close to each other and build a big tank. Instead of using these pipes, we connect all these plants in a big tank, and we have a floating system that is keeping the plants in the water. That can be done in an ebb and flow system. So imagine this is a big plant, big reservoir, big tank. Okay, and here we have a floatable material. This is most usually polystyrene. This floating material, and these there we have the uh, we have the uh, roots like this, and these are barely touching the plants, barely touching the water. Okay, we have roots like this, and we are keeping this in a way that the nutrient is easily being absorbed by the plants. Okay, now this is being absorbed by the plants. Now what happens in this is that this reservoir is very easy to maintain, so we do not require this as much amount of space as we require in NFT. So this requires even lesser space than NFT. Now this pump, the submersible pump, what it will do is from time to time it will fill the tray. It will be, if we can drain the tube also, we can maintain this level of water, and we can maintain the whatever nutrients that we require, we can maintain through here and here. Okay, it's very similar to NFT. The only thing is that we, instead of using different uh, pipes, we have transformed it into a single tub. So it is a very simple technique, very similar to NFT system, but only difference is that the plants are now even closer, and they are in a singular tub rather than multiple different channels, multiple different pipes. Okay, now what we will do is very simple, that this is a tray and a reservoir filled with nutrient solution. So this fill tray, this tub, we will keep filled at regular times, all the times, and we will regularly test its nutrient level. So it's very similar to NFT, but this time we have made it so that these are all plants are close together. Now the only problem with this is that if there is problem in this, let's say there is a problem in this whole nutrient solution. Let's say the water gets polluted somehow due to some mismanagement or some problem. This water gets polluted, so the diseases can spread in all these plants easier than it can in NFT. So NFT have this advantage. Although the plants are little bit spaced apart, the diseases will be harder to, disease will find harder to propagate in this in NFT than this media. So the diseases can be more easily propagated in this media, this system. So that is why ebb and flow is a technique that is utilized by hydroponic plants that have at least 2+ years of experience in uh, United States and America, Europe. So in Europe and United States, it's recommended that you have at least 1.5 to 2 years of experience in hydroponic systems before you get into ebb and flow. It's recommended that you start with NFT and then go to ebb and flow. But in India, we have a lot of consultancy firms. So if, for example, Farming Wave is building a farm, we already have 20 plus years of experience collectively. We have very old people who are working with us. So what we can do is we can directly start your ebb and flow farm also. And we can guide you towards this so that you can maintain the quality of water at all times. So is it clear? The major difference between NFT and ebb and flow is this: the density of plants that are per square meter. Okay, the density of plants is higher in ebb and flow, but it also means that the chances of ruining an entire crop is also higher because there is a singular reservoir and the plants are very not spaced very much apart. So any questions in the this? Uh, this creates a cycle of flushing the mediums with nutrients and air. Okay, so how this flushing happens is it's pretty much similar to NFT. So Vivek ji, you wanted to understand this last point, right? This creates cycle of flushing the medium with the nutrients and air, right? So what happens is that see in the NFT, what was happening is that the water was going from this end and coming out of this end. So what ends up happening is that we have to maintain the nutrient level and everything in this particular reservoir. Main reservoir में हमको maintain करना होता है. But what in this is what happens is this कि हमें एक साइड से डाल के हमको दूसरी साइड से पानी नहीं निकालना है. We have to maintain the water. Whenever we feel the need that water का level कम या ज्यादा हो रहा है in the upper tray, that what we can do is we can use this pump to fill the water and drain tube to reduce the. And if you want to mix the water, we can make it so that there's a constant mixture of water. The water goes from there and drains out from there. So we can mix the water and we can make sure that all times it is filled and the nutrient level of the filter is adequate. So this is the flushing of water. So when we use the drain pipe, we are flushing the water and we are using the submersible pump to fill the water in the tray. Okay, Mr. Manoj is asking which technique is highly commercial and economical for usage. So economical, it's ebb and flow. Easier to use is NFT. NFT is easier to manage, and ebb and flow is harder to manage, but it is more economical. You can earn more per square inch. You require less amount of plant is floating in one type of material. Okay, Gopal Yadav is asking what plant is floating in what type of material. The material most commonly used is polystyrene, and it's pretty much similar to thermocol but food grade quality. So we are looking one of the things that challenging thing is finding the right kind of food grade quality materials that are being used to float, right? So again, there are a lot of there's a lot of research on what kind of floating material can be used in ebb and flow techniques. A simple Google search will give you 10 more. Although in India, polystyrene is the most common, and we are using it. So I cannot tell you 10 different kinds other kinds of materials. But a simple Google search will do it for you, Mr. Gopal. Is it clear? Okay, let's move to next system, the drip irrigation system. Now, drip irrigation system is used in hydroponic systems. This is a drip irrigation system is used in hydroponic systems, but drip irrigation in itself, it's a precision farming system, which precision farming technique. So anytime we are using any component of farming, in which we want to reduce the wastage of resources, we term it as a precision farming system, precision farming technique. So if you're trying to reduce the wastage of water, we call it precision farming system, that is drip irrigation system, where we using to precisely use the water in the adequate quantity. Now, drip irrigation system. I think a lot of you have heard about drip irrigation systems because you might have also read it in your curriculum. If I'm not wrong, a lot of you are students, right? You might have heard about drip irrigation systems. So what happens in drip irrigation system is that you have a main reservoir. So you have a main reservoir. There are a lot of filtration system and backflush water systems. There is a lot of uh, here you can see the hydrocyclone filter. Then is a sand filter. There are backflush valves. There are flushing valves. So these are the things that do not. There are a lot technical in nature. So I'll give you a crux of it. Okay. So what happens is that we are providing water at a particular pressure. Okay, at a particular pressure in this pipe. So when this pressured water comes through these uh, pipes, so here you can see the pipe exit is blocked. So we have put a bend here. We have closed the pipe here. So the high pressure water is stuck between these pipes, this here and there. So it has only one opening, that is the uh, hose that we have made at the particular places that have the plants. So the water is only coming out of here. So what happens is that we know that there is a only one particular place that water can come out of. We know that we can control the flow of water at this particular place. So there is a whole chapter, the whole papers done in fluid mechanics, where we can effectively determine what will be the flow of water according to the pressure that we have at the source and what type of material is used, what is the size of the hole. We can control the amount of water that is coming out of these holes. Okay. So what ends up happening is we can design the system in a way that we only give enough water to the plant that is required by the plant. ओके शंभवी, मैं आपको हिंदी में भी बता देता हूँ. सिंपली हमारा क्रक्स ये है ड्रिप इरिगेशन सिस्टम का कि हमारे पास इनफ डेटा है जिससे कि हम जितना हमारा इन होल्स से पानी निकल रहा है, जहां जहां प्लांट्स हैं वहां होल्स हैं, वहां से जितना पानी निकल रहा है उसको हम बहुत इफेक्टिवली कंट्रोल कर सकते हैं. कंट्रोल कैसे कर सकते हैं? हमारे पास बहुत सारे पेपर्स हैं, फ्लूइड मैकेनिक्स में काफी सारे फॉर्मूलेज हैं. हम लोग पूरा सिस्टम इस तरीके से डिजाइन करते हैं कि अगर हमारा एक्स अमाउंट ऑफ प्रेशर यहाँ पे है, इस प्रेशर से हम यहाँ पे पानी भेज रहे हैं, तो इन होल्स से फॉर एग्जाम्पल 1 लीटर पर आवर पानी निकलेगा या 2 लीटर पर आवर पानी निकलेगा. कंट्रोल्ड वे में यहाँ से पानी निकलेगा जो कि बहुत कम होगा और उतना ही रिक्वायर निकलेगा जितना कि हमारे प्लांट को रिक्वायर्ड है, और ये डायरेक्टली प्लांट के रूट जोन में जाएगा. तो जो बाकी जगह हम लोग को पानी देने की कोई जरूरत नहीं है. तो ये हमारा इजिली 90% ऑफ द वाटर सेव कर लेता है कंपेयर टू फ्लड इरिगेशन. फ्लड में हमें पूरी जमीन को गीला करना पड़ता, बट वी हैव ओनली स्पेसिफिक प्लेसेस जिसको हम लोग यूज करते हैं. तो दिस ओके. सो मिस्टर अन्ना पात्रा इज आस्किंग, कैन स्प्रिंकलर इरिगेशन कैन बी यूज्ड इन हाइड्रोपोनिक्स? आंसर इज नो. सो दी हाइड्रोपोनिक्स इज अ वेरी स्पेसिफिक टाइप ऑफ फार्मिंग जिसमें प्रिसीजन फार्मिंग को भी हम एक नेक्स्ट लेवल पे लेके गए हैं. प्रिसीजन फार्मिंग इज ऑन नेक्स्ट लेवल इन हाइड्रोपोनिक्स. So we cannot use anything less precise than drip irrigation system. Drip irrigation system is one of those systems जिसमें हम हाइड्रोपोनिक्स यूज कर सकते हैं. इसके अलावा कोई भी ओपन फील्ड में यूज होने वाला सिस्टम इट्स वेरी हार्ड टू यूज ऑन हाइड्रोपोनिक्स बिकॉज उसमें वेस्टेज ज्यादा होगा. ओके. मिस्टर रेणुका इज आस्किंग, सर is there only those plants are transplanted can be grown in hydroponic systems, like what about crops which are sown by seed directly? So for it can be used, or is it not advisable for planting by seed? Okay, so the seed query, Renuka ji, we will be discussing this in the next slide. So when we will teach you about how hydroponics plants are grown, we will be talking about how the germination of the seeds happen in the hydroponic system. It will be a different topic. We will come to that. Now coming to this hydroponic system, this drip irrigation system, this was the idea कि हम लोग ओपन फील्ड में किस तरीके से करते हैं. This was to give you an idea how this is done in open field. Now just imagine we have a system like this. Sorry, we have a system where these plants, okay, we have a system like these plants. You can just replace these plants with some pots which are filled with hydroponics media, and we are using hydroponic system in there. So make it even more controlled. We will replace this area जहाँ पे हम लोग soil use करें. We will replace the soil and we will put a pot or a grow bag in which there will be hydroponic growing media like coconut coir or perlite mixture, where we can use it in a hydroponic system. So this drip irrigation system can be used in the hydroponic system. Okay, this will be an integral part of hydroponic systems for the larger plants. So NFT and DFT that we discussed, deep water culture, sorry, the ebb and flow system and nutrient film technique that we discussed was specifically for smaller plants that can be placed close together. Now for larger plants, drip irrigation system is a more effective way. So that can be adequately placed. We can have grow bags that can be filled with different types of growing media, and we can use drip irrigation system to provide water and nutrients. Okay, so this drip irrigation system, if you want me to go a little bit more technical, I can tell you the names of these lines, but I think that will be overkill. For now, it is very easier to understand that this is a system. We're using a main line. This is a main line, and we are using lateral lines. The main line is through which the water comes. The lateral lines are where the holes are. So the water is being transported from our main line to a lateral line where the holes are, and the amount of water that comes out from these holes is very much in our control. Okay, so this kind of irrigation system is widely used in hydroponic system. Okay, now coming to the last point of where I missed one thing. Okay, so all of you bear with me here. So these hoses that I talked to you about, right? I told you that we can control the amount of water that is coming out from here. Now these can be replaced by drippers also. So we do not always have to make a hole. What we can do is we can lay out these lines, we lay out these pipes, and we can punch a dripper into this that will control the flow in normal pipes also. Some pipes will come with pre-built holes, pre-built emitters. Emitter is the right term here. So some will come with a pre-built emitter, and some will come with a single line, with a lateral pipeline that we can punch holes and fix an emitter there. Okay, understood? Is there any question regarding the? So please give me some examples of plants that can be grown. Yeah, for examples of the plants that can be grown in these systems. Now, as far as the NFT and ebb and flow are concerned, the smaller plants like leafy vegetables, pretty much all kinds of leafy vegetables like spinach. There are all kinds of cabbages, romaine, lolo rosso. These kind of smaller plants, the basil, herbs like you know what are these? Rosemary, thyme. These can be grown in NFT and ebb and flow systems, which was this. NFT and ebb and flow. But when we are using drip irrigation system and we are using grow bags here, we are using it for slightly larger plants. For example, capsicum crops, your tomato, your cucumber, they are actually grown in these kind of systems because there will be a proper bush of this. They're fairly larger plants of tomatoes. I think vines of tomatoes that are grown in this kind of systems. So Apurva, is that clear? Okay. Now, okay. Now coming to the next type of system. This is, we have deep water culture. Now, I told you about this, these two kinds of systems, right? The NFT and the drip irrigation system. Okay, so everyone understood these two systems. Now, I told you there is a lot of mix and match going on. So the type of growing medium, the type of plants, the type of what, the way we give water to the plants, this gives rise to various hydroponic systems. This system can be used for agronomic crops. Agronomic crops, that is a very wide term, Miss Anchal. So there are a lot of crops that can be used, that can be grown in there, but it's a little bit different. Okay, so agronomic. So can you give me an specifically tell me what kind of agronomic crop are you talking about? Because okay, like wheat and rice. Okay, no, these kind of crops are not advisable to be. These are crops that are grown in clusters, so it's not very advisable to to give the same amount of attention to these crops. These are not very economical. Oh, as in agronomic. Okay, so agronomic also includes this cotton and everything. So they are actually being grown in not in our country, obviously. They are being grown in America. So potatoes also being grown in hydroponics. One interesting fact: ITC is using hydroponics, even a branch of hydroponics that is called aeroponics, to grow potato tubers. You understand potato tubers? These are potato seeds, basically, in general term. These are ITC is using these to actually produce potato tubers specifically for the potatoes that are used in our chips, specifically for Lays. So the Lays that you eat, the chips that you eat, the potatoes that are being used to grow these chips, these potatoes are uh, the seeds of these potatoes come from hydroponic systems by ITC. They are utilizing it for the last 15 years or so. I think 15 years was in 2000. Yeah, 2005 or so. I think 20 years now they're using it. Okay. So as far as the wheat rice is concerned, no, these crops are not very economical. Even potato is not economical. It is specifically for these companies that they have made economical for themselves, because Lay's has a very big, market in India. They're able to justify the cost. But no, the agronomic crops, we will not be using hydroponic systems. These are specifically for crops that are slightly, that require slightly better care. Now, coming to the drip horticulture system. Now, drip horticulture method, it is a way of growing plant in nutrient-rich water solution. Now, this again is a type of mixture of NFT and this ebb and flow system. But in this, what happens is there is a huge tank. There's not a separate place for water to be given. So there's a singular tank, and the uh, pots, sometimes there will be smaller pots, the net pots, or sometimes there will be styrofoam or styrene that will be placed in these containers, and the plants will be placed on top of them, and it works effectively as similar as NFT and ebb and flow. I think it's a very self-explaining thing that how this works. There's an air pump and air stone. There's a nutrient solution whose nutrient value is to be maintained at all times. And there is a styrofoam sheet that keeps floating. No, okay, styrofoam is also there. Polystyrene and styrofoam. So styrofoam is also there. The styrofoam helps to float these plants so that they do not submerge totally. This is at somewhere in between NFT systems, which you witnessed a little while, learned about a little while, and the ebb and flow. It's somewhere in between. The mix and match. As I've told you, these are basically 3-4 systems. Then mix and matches will keep on appearing. There'll be, the tank system will be from DWC, the plant system will be from grow bag techniques, and we can have a totally different kind of system from there. So whatever is feasible for a particular crop in a particular area in particular region, there will be different kinds of hydroponic system that will evolve. So deep water culture, what happens in this is that we are directly growing it in a nutrient solution. There is no film that is required because we are using styrofoam. Now, styrofoam has a very short shelf life. So every 1 year or so, you have to change the styrofoam and have to make sure that it does not start to degrade. Otherwise, it will, have you heard the use of microplastics? So the plastics do not actually, yeah, styrofoam is a very similar thing to, styrofoam is very similar to thermocol in its, base form, but it's a slightly stable version of thermocol because it will, not dissolve completely and not emit the, it will not pollute the water easily. So every once in a while, you have to change the styrofoam. Secondly, I think diseases are attacked easily in this system. Yes, Ms. Akshay, the diseases can attack easily in this system. So that is the reason that this is also one of those systems that are introduced to newer hydroponic enthusiasts later, a couple of years after they have had experience in NFTs and different other systems. Okay, and also in countries like America, where they are large scale, the large scale production of cabbages and everything, DWC is the most prevalent technique. NFT comes second in America. In America, the DWC is more relevant technique that is used in for growing everyday vegetables. Okay, because they have a lot of experience. A lot of these farms have a lot of user experience, so they're able to use DWC very well. For a starting people, the risk of diseases is a little bit higher than nutrient film technique. Now, this is very similar to NFT. As I told you, there's an air stone that will keep it oxygenated. Now, as there is a lot of air stone is very near to this plants. There is no gap between the nutrient levels of the actual reservoir because the reservoir is same here. So if we go back to this ebb and flow in this system, the reservoir is different from the place where the plants are growing. So we will have slightly better growth of plants in the DWC system. Is that clear? But the risk of diseases will also be high. Is it clear? If you have any problem till here, you can tell me. Then we'll move with the hydroponic media. Okay, now let's moving on to the different types of hydroponic medium. Now, when it comes to hydroponic systems, the growing media is very important. Now, every growing media will have its own set of challenges, its own set of advantages. So we have to find the kind of crops that we want to grow, the kind of fruits that particular crop will have, and also the kind of system we have. It's a lot of interconnecting factors that we will be able to, understand that what kind of system will be media will be best for our system. Now, clay aggregates. The clay pellets are the most commonly used media for NFT system. So NFT system, you see, the roots have to be fibrous and always touching water. They do not need to hold on to something. So the support that is required by NFT system, the plants in NFT system require a support where the system can actually give them a body, give the roots a very good hold the roots so that plant can stay upright. तो जो NFT सिस्टम में हमको ग्रोइंग मीडिया चाहिए होता है वो थोड़ा हार्ड चाहिए होता है, जैसे कि क्ले बॉल्स हैं, वो बहुत लाइट होती हैं बट थोड़ी हार्ड होती हैं, तो दे विल लैच ऑन टू द रूट्स, so the roots will latch onto this, and sometimes roots will pass from one end of this clay palette to other. So these are full of holes. So the roots can pass from this end to this end. This is clay. This is all natural. These are not the kind of material that will, these can biodegrade at after some time. These are natural materials. These will biodegrade, the natural materials, but they will not biodegrade as easily as in a couple of months. They will not start rotting in couple of months. So these are stable enough that they can be used in NFT systems. Now this have these maintain a neutral pH also, and they do not have any nutritional content. So as I told you, these media need to be like they do not have any natural nutritional content. Otherwise, they will have microbial growth also. Okay. Now, clay pellets, these are most commonly used in NFT systems here in India. Now, coir, actually the R is omitted, maybe a mistake from our end. I apologize for that. This is COIR, the coir, the cocoa coir or cocoa peat. This is one of the most common systems which are used, most common media which is used for larger plants. So the larger plants, what happens is you cannot hold them with couple of these clay pellets. The roots are very fibrous. They need to hold on to something that is very similar to soil. एक soil की properties वाला, soil के जैसे texture वाला हमें एक मीडिया चाहिए लार्जर प्लांट्स के लिए, जो लैच ऑन कर सके, जिसमें कि रूट्स लैच ऑन कर सके अच्छे से, ताकि वो बड़े प्लांट्स को सपोर्ट कर सके. हम लोग बात करें टोमेटो की, हम लोग बात करें क्यूकम्बर की, कैप्सिकम की, ये बड़े प्लांट्स हैं. टोमेटो की तो वाइन्स बहुत ज्यादा लंबी हो जाती है. सो देन एडिशनली देयर अ वेट ऑफ टोमेटोज एज वेल. सो इस केस में वी नीड अ वेरी सॉइल लाइक टेक्सचर दैट इज प्रोवाइडेड विद कोकोपीट. एक और कुछ नहीं है, ये सिर्फ जो कोकोनट के बाहर का छिलका होता है उसको हस्क बनाते हैं, थोड़ा और अच्छे से पीस के बनाते हैं. So cocoa coir is simply the fibers of outer shell of coconut. This is very commonly used in India, very easily available in India also. The southern parts, so the coastal parts, all do this business because cocoa coir is itself a very kind of a byproduct of coconut, and it will start biodegrading after a while. So in that initial 2-3 year period, जहाँ पे ये biodegrade नहीं हो रहा है, we can utilize it in hydroponics. So it's a very readily available media also. So these first two are the most commonly used media in India. Now, third most commonly used media in India for the NFT systems and NFT systems specifically and DWC systems in grow storm. This is on the third number. And second in NFT and for small plants. This is pretty much similar to clay aggregate. सिर्फ इसका जो बनावट है वो थोड़ी अलग है. इट्स ऑल्सो एयर और वाटर रिटेंशन थोड़ी ज्यादा है. सो इसका एयर अंदर से ये भी खोखला है, जिस तरीके से क्ले खोखला है उसी तरीके से ये भी बहुत पोरस है अंदर से. दिस इज ऑल्सो वेरी सिमिलर टू क्ले एग्रीगेट, बट दिस इज मेड फ्रॉम ग्लास वेस्ट. नाउ दिस will hold a lot of water. This will allow the roots to penetrate. This will allow the roots to hold on also. This will not be very hard, very heavy, so कि ये roots को तोड़ दे, उतना heavy नहीं होगा. But this will be enough. This will be enough hard that it will hold the roots in place. Now these three are the most commonly used growing media. Now then we have sand. Now sand, as you know, sand में कोई माइक्रोबियल एक्टिविटी नहीं होती. सैंड इन इटसेल्फ कैन नॉट सपोर्ट लाइफ. आप देखते हो रेगिस्तान में देयर आर नो प्लांट्स इन अ डेजर्ट. देयर रेयरली एनी प्लांट्स इन डेजर्ट. जहां पे आपको मिलेंगे तो प्लेसेस यू फाइंड देम, दे विल बी प्लेसेस वेयर देयर इज अ मिक्सचर ऑफ सिल्ट एंड क्ले समवेयर डीप beneath the sand. Only there the cactuses also grow. Pure sand it is not possible to grow a lot of plants. Very rare that in pure sand some plants will grow. Okay, so this is a very, again, but it is natural. So the only thing with sand is that it has to be sterilized well before use, between use. Time to time इसको sterilize करना पड़ता है, so make sure there is no microbial activity. So because as I told you, in rare cases cactuses can grow in deserts, right? So there is a slight possibility that it supports life, but for hydroponic systems, we have to sterilize it after every use. Now, it's also readily available, but coco coir actually works better for us in India. So there are there are a lot of different factors for that. First of all, its availability. The weight is also an thing. The water retention is also one of the major major factors that we use coco coir peat over sand. But this is another different thing. For now, you should understand that sand is, although it's readily available, it's easier to use coco coir. Okay, it's easier to use. Now, then coming to perlite. Now, perlite and grave. Okay, this perlite is a volcanic rock. Okay, so this is a small pebbles. Now, when we need to improve the texture of this coco coir, it's like if we are trying to mimic soil. Soil also has small pebbles, right? So we need to mimic that in cocoa husk, cocoa peat in coir. What it will do is it will provide better aeration, because cocoa husk will tightly bind together, so it can be jam packed into the grow bags. So we need a little bit of aeration. So these slight pebbles in between, what will they it will do is it will provide a good pathway for the airflow flow. So perlite is often mixed with cocoa peat. It itself can also be used as a growing media. Although it's a little expensive, so we do not use only perlite in India, but in some countries it is used in DWC cultures. Okay. Then we have gravel. Again, my mistake. L is omitted here. So gravel is inexpensive, but the thing is, uh, again, because gravel is slightly heavier, so it's hard to transport. Otherwise, it's a excellent growing media. It is compared to clay balls and this grow stone and clay aggregate. But clay pellets in are slightly more airy, and they're very light to transport. So transportation factor comes into play, and also it reduces the strain on the actual system that we're using. So the plants also have weight. If the growing media is light, it's easier. It increases the shelf, increases the life of the system itself. Okay, no problem, Manoj. You can in the that we will give you, Mr. Manoj, we will give you a recording in there. You can take the notes then. For now, you can just write the name and you can leave it. Okay. So during the revision part, you can take the detailed notes. For now, you only need to take the notes of, just write the headlines. So as to do not forget that this was the point that was being talked about. Okay. 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 So these are different types of growing media. Obviously, we have only talked about 6. These are the ones that are used in India. The first 3 are more common. The last 3 are relatively rare. But for the most part, the 6 are just not even the surface of what is used as growing media. Growing media are the multiple growing media that we have not covered here. So if you find time, just do a quick Google search and you will find 10 of different types of growing media that even better than this one, maybe even airier than these, but because of other factors like transportability and availability, we end up using these 6. Okay. Now, any more questions about the growing media? So we can move to the basics. We can move to the basics of hydroponics. Okay, so what I will do is I will just, to keep you more interested in tomorrow's lecture, what I will do is I will just give you a quick idea about how hydroponics functions. So if you want, you can take notes and you can do a little bit of your research, so you can ask even more interesting questions tomorrow. But what I will do is I will just tease you a little bit and give you a rough idea about what are the basics of hydroponics. So we can discuss the more technical part from tomorrow on. Okay. So I will address one of the attendees' questions that can we grow the plants from seeds? So I'll be addressing that also. So this is the basics of hydroponics. So we will be go through a preparation stage, crop selection and preparation layout, preparing the layout of timeline also. Then we will move toward the sowing stage. So addressing the question of that one attendee, we can directly sow a seed itself, seed first, and then we can wait for it to grow into a sapling, and then we can transplant. Some cases in hydroponics, we can directly plant the seed also. Okay. Then we have the transplanting stage. Now transplanting, as I told you, there are some places where you do not have to transplant. We can directly do the seed sowing also. Then in the most cases where transplantation is a very important step, we end up doing it in a grow bag, or we can do it in a nutrient bed. Then we have growth, the growing bag and main nutrient bed. Now there will be a harvesting with quality checks, and then cleaning and maintenance. So we will discuss all these in detail from tomorrow onwards. Okay, tomorrow will be a more technical session, although I think it became a little bit technical today also, but I think tomorrow will be even more informative. Okay, so I hope it was satisfying for you all. So what we'll do is tomorrow is we will make a first 10 minutes, we'll make about any kind of questions that you have from today's session. So if you're okay with that, so you can prepare a questions from today's session, and we can discuss this in the first 10 minutes. So Mr. Sambhavi, we will address this question tomorrow. So license and permission to start. So okay, so about licenses and permissions and subsidies and everything, we will be talking about in day 3. But okay, so keep a tab on that, and keep that question with you. So I think Mr. Chandan will come now. He is the founder of Farming Way and a good friend of mine. He will address you for the one last time and give you a leaving remark. So Chandan, please take over.
Hello everyone. आज का जो सेशन था ये बेसिक्स ऑफ हाइड्रोपोनिक्स। अगर इसमें कुछ कंफ्यूजन हो या कोई क्वेश्चंस हो तो वो आप अभी एक बार 1-2 मिनट 5 मिनट हम डिस्कस कर सकते हैं, क्योंकि टाइम तो हो गया है। बट कुछ ऐसा क्वेश्चंस हो जो अभी चल रहा हो कि कल अगर वो भूल जाए या फिर अभी पूछना चाहिए था, तो वो एक बार आप पूछ सकते हैं।
बिल्कुल, I will welcome that. So as far as the license and permission to start, I think Sambhavi, I addressed that. We will discuss it on day 3. So keep that with yourself, okay?
Thank you so much, sir. एंड या आई विल अगेन से, आज के अगर आपके कोई भी क्वेश्चन है जो इस सेशन में आपने देखा है, इस स्लाइड्स में जितने चीजें थी, आपका अगर इनसे रिलेटेड कोई क्वेश्चन है तो आई विल बी लाइक कि आज ही कंप्लीट कर लो, वो ज्यादा बेटर रहेगा रादर देन फॉर टुमारो, बिकॉज आई डोंट थिंक सो कि वो याद रहता है या स्किप हो जाता है। इट्स बेटर कि आज की क्वेश्चन आप आज ही कंप्लीट कर लो। जस्ट टेक 2 minutes एंड थोरोली चेक कि आपने क्या क्या सीखा। इफ एनीवन हैज एनी डाउट तो जस्ट लेट अस, विल वेट फॉर 2 minutes, नो इशू। एंड तब तक मैं आपको एक बार ही मैं आपको चैनल की लिंक भेज रही हूँ, जस्ट डू फॉलो अस, और आपको यहाँ पे अपडेट्स मिलते रहेंगे। आई हैव गिवन यू डिफरेंट लिंक्स लाइक इंस्टाग्राम पे आपको रिसेंट हमारे जो भी अपडेट्स आते हैं वो आपको पता चल जाएंगे। इवन काफी सारे रजिस्ट्रेशन हमारे इंस्टाग्राम के थ्रू आए हैं, तो जस्ट फॉलो आवर इंस्टाग्राम। आई एम सेंडिंग यू लिंक्डइन प्रोफाइल, वहां पे आपको कंपनी के अपडेट्स मिलेंगे। लाइक सपोज वी आर हायरिंग समवन, उस चीज के गवर्नमेंट हायरिंग, प्राइवेट हायरिंग, सारे अपडेट्स ब्लॉग के तरीके से आपको लिंक्डइन पे मिलेंगे। एंड यूट्यूब, जो आपको रिकॉर्डेड सेशन स्टूडेंट्स मांग रहे हैं, वो आपको रिकॉर्डेड सेशन जो मिलेंगे वो यूट्यूब पे ही मिलेंगे। सो जस्ट फॉलो, सब्सक्राइब यूट्यूब, and then you will get all the information. So make sure you subscribe all these two things. And now you can go for your questions. Sir, someone is asking where are you based? The main office.
Where are you based?
Main-
Main office. You're asking for the main office.
मेन ऑफिस जो है हमारा ग्रेटर नोएडा पड़ता है, गलगोटिया यूनिवर्सिटी के जस्ट पीछे है। ये हमारा हेड ऑफिस है, मेन ऑफिस है। यहीं हमारा एक R&D फार्म भी है, जहाँ पे हम डिफरेंट टाइप ऑफ क्रॉप्स ग्रो कर रहे हैं। उसमें न्यूट्रिएंट लेवल कितना होना चाहिए, हम कौन कौन से क्रॉप को और अच्छे तरीके से ग्रो कर सकते हैं, और क्या पेस्टिसाइड्स एंड यूज कर सकते हैं हम लोग बिना रेसिड्यू उसमें गए हुए। तो वो सारी चीजें हम R&D करते हैं। कौन कौन सी सीड्स वैरायटी हमें वाइबल है, कौन सी सीड्स की जो वैरायटी है वो उसकी मोर देन मतलब जो अदर वैरायटी है उससे ज्यादा यील्ड आ रही है। तो वो सारी चीजें हम R&D भी करते हैं। हमारा R&D का फार्म भी यहीं पे है, धनकौर पड़ता है। और हमारा ऑफिस भी ऑलमोस्ट 10 किलोमीटर के डिफरेंस में है। तो अगर कोई विजिट भी करना चाहे तो आप लोगों में से कर सकते हैं। हाँ, NCR में
Yes,
ही
and
पड़ता है।
even yes, and sir, internship भी provide कराते हैं. So guys, if you want to
हाँ
do internship then either often, so you can connect with them also.
हाँ, इंटर्नशिप प्रोग्राम में भी आप ज्वाइन कर सकते हैं। उसके अलावा हमारा रिक्रूटमेंट भी रहता है कि कभी हमें एग्रोनॉमिस्ट की ज़रूरत है, तो वो भी हम उसके लिए भी डालते हैं कि अगर आपको नॉलेज है आप कर सकते हैं, या फिर अगर नॉलेज नहीं है तो आप यहाँ पे ट्रेनिंग सेशन लेकर के जो हैंड्स ऑन हम ट्रेनिंग करवाते हैं उसमें भी आप पार्टिसिपेट कर सकते हैं। वहाँ से सीख के, या फिर 1-2-3 महीने का इंटर्नशिप प्रोग्राम है उसमें आप करके फिर हम उसको अपॉइंट कर देते हैं एग्रोनॉमिस्ट के लिए। डिफरेंट डिफरेंट टाइप के हमारे यहाँ पे जॉब रोल होते हैं, जैसे VDM हो गया, या फिर हम लोग क्योंकि स्ट्रक्चर से रिलेटेड भी डील करते हैं तो उन सब चीज़ों में भी रहता है। तो आज आप लोगों ने जो बेसिक्स ऑफ हाइड्रोपोनिक्स सीखा उसमें बेसिकली ये था कि कितने टाइप्स के हाइड्रोपोनिक्स होते हैं, हमें कौन सी हाइड्रोपोनिक्स चूज करनी चाहिए। बहुत सारे फैक्टर्स हैं, जैसे कि आप कौन से सिटीज में रह रहे हैं। जैसे कि आप बिहार में रह रहे हैं, या फिर कुछ ऐसे सिटीज में रह रहे हैं जहाँ पे जो इसका है कंजम्पशन है उस चीज का वो नहीं है। जैसे हम बात करें, लेटस है, केल है, बेसिल है, तो कुछ कई जगह पे ऐसे हैं इसका नाम ही नहीं पता है। तो हम वो ग्रो करके करेंगे क्या, और अगर ग्रो कर लिए तो हमें जो है ट्रांसपोर्टेशन करना है कि जैसे अब दिल्ली भेजना है तो वो उसमें भी लॉसेस होते हैं। और उसके अलावा ऐसा भी हो सकता है कि हमें मार्केट उसका ना मिल रहा हो। तो हम क्या करते हैं ना कि जो अपना सिटीज है उसके हिसाब से वहाँ का वेदर कैसा है उस हिसाब से हम क्रॉप सेलेक्ट करते हैं। क्रॉप सिलेक्शन के बाद हम सेलेक्ट करते हैं कि ये क्रॉप कौन सी सिस्टम में उगती है। जैसा कि अक्षय जी ने बताया कि जो छोटे प्लांट्स होते हैं जैसे कि आपका लीफी वेजिटेबल्स है वो हम NFT, DFT, इवन फ्लो टेक्निक में ग्रो करते हैं। तो उस हिसाब से हम क्रॉप सेलेक्ट, अगर हमारा क्रॉप सिलेक्शन हो गया कि हमें कौन से एरिया में करनी है वो अच्छे तरीके से उसका सिस्टम चूज किए। सिस्टम चूज करने के बाद फिर हम वो क्रॉप पेपर है वो हम ऐसे भी जगह पे कर सकते हैं जहाँ पे इतना ज्यादा पॉपुलेशन नहीं है इस चीज का, उतना ज्यादा मार्केट नहीं, क्योंकि उसको इजीली। बाकी टेक्निकल फैक्टर्स हैं, टेक्निकल टर्म्स हैं, वो कल हम समझेंगे। इसी पीएच वो सारी चीजें न्यूट्रिएंट पे कैसे क्या हम न्यूट्रिएंट को हैंडल करते हैं, क्या न्यूट्रिएंट देते हैं, कैसे कितना ले, सारी चीजें नेक्स्ट डे हम डिस्कस करेंगे। हाँ, MBA स्टूडेंट के लिए भी रिक्वायरमेंट होती है। आप एग्रीकल्चर बैकग्राउंड से हो तो भी रिक्वायरमेंट होती है। आप फार्मिंग वेब पे जब जाएंगे तो वहाँ पे आप देखे होंगे कि सारी चीज़ों का जैसे कि हायरिंग डाला रहता है कि आप अगर उस पे एक्टिव रहेंगे तो आपको पता चलता रहेगा कि कौन सा कब हायरिंग किस चीज़ की हो रही है, तो उस हिसाब से आप आ सकते हैं।
जी हॉर्टिकल्चर स्टूडेंट्स के लिए भी रिक्वायरमेंट होती है, वही चंदन सर बता रहे
और कोई कंफ्यूजन हो या क्वेश्चंस हो तो आप लोग अभी पूछ सकते हैं। 2-3 मिनट और टाइम है। 2 मिनट। हाँ, मई में भी आप इंटर्नशिप के लिए अप्लाई कर सकते हैं। अलग अलग लोकेशन पे हमारा रहता है। अगर मई में करना चाहते हैं तो आप अलवर लोकेशन पे कर सकते हैं, जो राजस्थान में पड़ता है। वैसे तो दिल्ली से ओनली 180 किलोमीटर के आसपास डिस्टेंस है दिल्ली एनसीआर से। आंध्र प्रदेश में अभी तो ऑफिस नहीं है, बट अपने कुछ फार्म्स हैं जिसको आप विजिट कर सकते हैं। इंटर्नशिप आप कर सकते हैं, झारखंड में भी कर सकते हैं। हैंड्स ऑन ट्रेनिंग आपको चाहिए, अगर मेजोरिटी होगी वहाँ पे तो हम हैंड्स ऑन ट्रेनिंग भी वहाँ पे कर सकते हैं। बट हम प्रेफर करते हैं कि दिल्ली एनसीआर में ही हो। हाँ श्योर, आपको मध्य प्रदेश और आंध्र प्रदेश, इन सब जगहों पे जो भी है आपको मिल जाएगी। जैसे आपका सेशन एंड होगा 3 डेज में, तो आपको सारा इंफॉर्मेशन मिल जाएगा। और आपको जो आपका ग्रुप होगा उसमें हम कुछ नोट्स भी प्रोवाइड करेंगे। उसमें जो भी इंटरेस्टेड होंगे इंटर्नशिप के लिए तो हम सेलेक्ट भी करेंगे परफॉर्मेंस के हिसाब से। हम एक आप समझिए कि टेस्ट ले लेंगे कि हमने जो 3 डेज का प्रोग्राम किया है उसमें आप कितना क्या परफॉर्म कर रहे हैं, उस बेसिस पे भी हम इंटर्नशिप अपॉर्चुनिटी दे सकते हैं। तो ये है कि आप कितना अच्छा सीख पा रहे हैं, क्या क्या हमने आपको बताया उसमें से क्या क्या आप कितना ग्रैब कर पा रहे हैं, वो भी एक चीज़ पता चलेगा। तो हम उस बेसिस पे भी इंटर्नशिप के लिए हायर कर सकते हैं। ठीक है तनुजा जी।
Okay. Any other query? Sir, do you have any branch in Northeast? Northeast side, you said?
नॉर्थ ईस्ट। आप एक बार स्टेट बताएंगे कौन सी स्टेट? नहीं, अभी इधर तो नहीं है। आसाम तरफ तो नहीं है। उड़ीसा में आप कर सकते हैं, उड़ीसा एक लोकेशन है। ये मैं आपको ना एक लिस्ट शेयर कर दूंगा कि कौन कौन से जगह पे हमारा है ये ब्रांच। आप जहाँ जहाँ पे इंटर्नशिप प्रोग्राम या विजिट कर सकते हैं वो मैं आपको एक शेयर ही कर दूंगा, है ना। इजी रहेगा। राउरकेला में है,
Yes.
उड़ीसा में।
Yes, sir. I think list is a better option.
हम्म।
Okay, students, I will provide you the list of the locations. No worries. Okay, we'll close the session and कल मिलते हैं with new technical things. Okay, thank you so much, sir.
थैंक
It's
यू।
a great session. Okay, thank you so much, students. कल 4 बजे will join the meet. Okay, students.
ओके,
Okay, thank you, sir.
थैंक यू।